students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is the power law of logarithms. In fact, this is the second session on the power law of logarithms. We had one session, the previous session was also on this topic. Over there we had proved the power law of logarithms using the product rule of logarithms. But that method had certain limitations. If you want to know about the limitations, you please watch my previous video on this topic. And in our today's session, we will be knowing about the generalized proof of the power law of logarithms. And along with the proof, we will be doing or we will be solving two more problems, which will be taking the help of the power law of logarithms. Okay. And the second question will be somewhat challenging. So I would request you to stay till the end of the session so that you know what is the question and you know how to solve it. Okay. So without any further delay, let us start with our today's session. And E stands for the base. E will be the base of the log terms that we will be using. So A has to be greater than 0 and A cannot be equal to 1. And x will be the argument of the log terms. So x has to be a positive number greater than 0. And m will be the power of x. X is the argument which will be having the power as n. And it will also be the coefficient. How does it become the coefficient? We will be knowing. And m is any real number. Okay. So let us start with our today's session. This is the power law of logarithms. Log of x raised to the power of m to the base a is equal to m times log of x to the base a. And in our previous session, I had written this term first, and in our today's session, I have written this term first. Since it is an equation, it doesn't matter which term you write on the left hand side. Okay? Because both have the same value. Now we come to the proof part of this power law of logarithms. So we start with the left hand side. It is log of x raised to the power of n to the base e. This can be written as log to the base e, and in place of x we are writing e raised to the power of log of x to the base e. I have shown you this property of logarithms in my video on 4 important properties of logarithms. I have shown you, along with the other 3 properties, I have shown you that x can be written in this form. How can it be written and why can it be written in this form? I have explained this method, okay, in that session. And if you want to know about this property, how can we write x in this form, you please watch my video on 4 important advanced properties of logarithms. Okay. And this whole thing is getting raised to the power of m. And now we will be using the power law of exponents, which says that e raised to the power of m whole raised to the power of n is equal to e raised to the power of m times n. So over here it is e raised to the power of log of x to the base e, and this whole is raised to the power of n. So we can write this as log to the base a. This part will remain the same and the power gets changed. It is e raised to the power of m times log of x to the base a. Okay. And this is another property of logarithms also given in that session, also explained in that session on 4 important advanced properties on logarithms. That if you have log of some number which has a power and the base is also equal to that number, then the value of that log term will be equal to the power. So this is equal to m times log of x to the base e. which is the right hand side of the power law, this equation. Okay. So we have proved the power law of logarithms. Now let us go to the questions part. The first question says, prove log of 1 over x to the base e is equal to negative log of x to the base e. So we come to the proof. Log of 1 over x to the base e. Now this 1 over x can be written as log of x raised to the power of negative 1, and the base remains the same, it is to the base a. And since the power is negative 1, m is negative 1, m can be brought to the coefficient place. So this will be equal to negative 1 times log of x to the base a, and we do not write negative 1, it is negative log of x to the base a. So we have proved this. Coming to the next question, the second question. Evaluate log of 36 to the base 3 minus 2 times log of 2 to the base 3 without a calculator. Okay. So, the first term we keep it as it is. We will be using the power law of logarithms, and we will be using the division or the quotient rule of logarithms in order to get the answer. Okay. So, first term we keep it as it is. We are seeing there is the coefficient of 2 which can be taken to the power part of the argument. So, it becomes log of 36 to the base 3 minus log of 2 raised to the power of 2 to the base 3. And 2 raised to the power of 2 is of course equal to 4. So, it is log of 36 to the base 3 minus log of 4 to the base 3. Now, we see the two log terms are having the same base, that is 3 in this case, and they are connected by this minus sign. They are getting subtracted. So, we will be using the division rule or the quotient rule of logarithms, and this will be equal to log, the base remains the same, it is 3, but the arguments get divided. It is the first argument divided by the second argument, that is 36 over 4. And 36 over 4 is equal to 9, so this is equal to log of 9 to the base 3. And what is the value of log of 9 to the base 3? For that, we write 9 as 3 square. Okay. So, we write this as log of 3 raised to the power of 2 to the base 3. And this 2 is the power of the argument which can be brought down to the coefficient place. So, this will be equal to 2 times log of 3 to the base 3. And we know log of a to the base a is always equal to 1. So, log of 3 to the base 3 is 1. So, this is 2 times 1, which is equal to 2. Therefore, log 36 to the base 3 minus 2 times log of 2 to the base 3 is equal to 2. Okay. So, students, this brings us to the end of this session. Please like, share and subscribe if you have found this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.